Okay, let's go. Hello, everyone. Welcome back to the stream. So, on Tuesday, we resumed working on the compiler and we did mostly some small changes. The main things we worked on Tuesday were changing the linker. We rewrote this to prune functions that are not used and avoid like making the image bigger than it needs to be. And we added one more step in the minimization process, which turned out to not be that useful, but it's still one more rule that simplifies the code a tiny bit. Now, this evening, we are starting a significant project as part of the compiler work that's going to take us, I expect, multiple streams, probably multiple weeks to go through, and that is adding tests because we have very, very few tests so far, in no small part because since as of the last month when I took a break, we were getting very close to being at a point where we could actually compile programs, and I wanted to just get to a point where we can actually run the compiler. We are at this point. We can now actually run the compiler, which means it's time to actually start writing end-to-end tests that try to compile files and check that everything happens as expected. And in the process, we can fix old broken tests, and we can also add tests for all the different phases that we've implemented so far. So this is going to be a lot of work, and there is no better way to get started than by getting started, I suppose. So let's have a look at the current state of the tests. I'm expecting it to be broken because it's been a while since we've done any work to even check that they compile. So let's see how that goes. So far, so good. Hello, how are you? Yeah, I've restarted on Tuesday. Took a bit of a break, but it's good to be back. So yeah, if you were not there, I'm gonna be starting a big project today. I am gonna be working on tests for the foreseeable future because we have very few tests and they're currently broken. And now that we are at a point where we can actually compile very simple programs, then we can start building a harness of like solid tests, especially end-to-end tests, which means when we start building more things down the line, we'll have those tests to guide us to make sure we're not breaking anything. Okay, so some things in the tests are broken. That's fine. Let's go have a look at what's broken so far. I had this old file that was just running some of the faces, but it's not very accurate anymore. As a result, I think it breaks the passing test down the line. Yes, okay. Oops. Oh, our notification is partially hidden, so that's fine. Okay, so that's I suspect that this parse module is the correct one for the parser. We need to fix that, and we need to fix this whole thing because that is extremely wrong. See, this is pre-refactoring of the diagnosis stuff. So before we had the ability to record diagnostics, warnings, and stuff, so we just have this monad error M, which is completely wrong. In fact, why do we require that? Oh, we require it for the run test compiler here. Okay. So I think what we need to do here, well, we already have internal diagnosis here. I suppose we can just set monad diagnosis. That should be enough to do this. If we look at the parsing, parse module just requires monad diagnosis. Okay, perfect. So this on left needs to be, so this can just be removed altogether. This is gonna just be in the monad diagnosis there. This run diagnosis is therefore probably not needed either. This is, what is the module name? There we go. Okay. So this is just run analyze module then. Okay. And running a test compiler. Hello, how are you? So running the test compiler should therefore, this is no longer a run except t. That makes no sense anymore. This is going to have to be, if we look back at our diagnosis thing, we have this monad diagnosis thing. This is going to be a run diagnosis, I think. Do we have a run diagnosis t? We do, perfect. So this is going to be a run diagnosis t. And that gives us in the underlying monad, a sequence of diagnostics and a maybe value. And we want to translate that into what this test helper expects, which is either a string or an A. Okay, so we can do that with diagnostics result. That's what we get from running this. Now the question is, since some of those helpers, we're probably going to rewrite all of this anyway. Yeah, we're probably going to rewrite all of this anyway, so I'm just going to make the bare minimum for this to compile for now. This expects just either some errors or an A value. I'm going to ignore the warnings and only returns the A string there when there are errors. So this is just going to be a case of the result of, we get a value that's perfect, we return that. I guess I can just rewrite this as actually as being result, and on nothing, what do? We return a pure of left show diagnostics. Okay. Hopefully that fixes some of our issues. Let's see. Yes, here I have explicitly the except t, that's incorrect. So this needs to be instead a diagnosis t, which doesn't have an argument. Yes, of course. So in the case, so this is would be an f map just of the right of the result, I believe. At this point, this is not much more readable, so I might replace this with a case result of. Ooh, what happened there? Nothing, and we return. I can just make a pure here, I suppose. Left show diagnostics, just a value. Pure, well, right of the value. That's a bit more verbose, but I think in this case it's a tiny bit more readable. Okay, what happened there? No instance of monad M. Interesting. Oh yeah, indeed, I don't have an monad M constraint here, which means the do block here doesn't work. That's trivial to fix. What's next? Okay, so here I am doing... Okay. So here that's so old. This test code is so old that it's still expecting parse module to give me an either. It's been a long time since that's been true, because the parser gives us instead a parse module gives us something in M, where M is a monad diagnosis. Which means if we go back here, this parse module needs to be instead doing, and I might want to add some kind of... Can I just do the run test compiler that I had just right there? Yeah, probably. I can probably just do a run test compiler, which requires the file path. Okay. Do I have the file path? That's the test input file, I believe. Yeah, there we go. And the action I want to do is parse of the source. And that should be all I need. Except that this expects this to have... So what I can do here is an on left M, and this is just gonna be error, I guess. Error.show. No, just error. Okay. That should be fine. Am I forgetting something? I might need to import the compile module that we've just fixed. Aha. That's the same kind of problem. Okay. So maybe I want to add a small helper here by removing the import of the parsing here. Add a little helper called parse module that takes a file path, some text, and returns. All of those are in IO, right? Well, I guess I can make them return just some... What does parse module return, actually? Just a module. There we go. Parse module will be given the file path and source code. It's going to be exactly that. And it's fine to use error here because this is in the test code and this will be caught by the test runner. So now this is just parse module test input file source. And now this is parse module. There we go. Except, of course, I did not rename things properly. This is the file path, and this is the source code. Named here. Okay. What's broken now? Oh yeah, now this, by doing the error, is not monadic at all. So now this is just let AST equal, which I guess I could rewrite as there we go. And here, likewise. Okay. Oh, this is no longer, yeah. To the point that I don't know if I still need this let here. Ah. Ah, okay, that's an issue. This expects the thing underneath to be some kind of monad. But run test compiler does not necessarily is not necessarily in one. I guess I could run identity that. Okay. But since I'm gonna just run identity this, I could also maybe it makes more sense to just not make it return something in a monad if I don't really need this to be in a monad in the first place. So maybe run test compiler can just give me an either string A. It's no longer a monad, and now this is do I have actually a diagnosis monad? Or do I just have diagnosis T and I don't have diagnosis on its own? No, I have it. Diagnosis is diagnosis T identity. Perfect. And do I have run diagnosis? I do have run diagnosis. Great. So this is that now. That's going to break a few things, but this should be better. And now this is just a left error of this. Now we're seeing the consequences of the change. Here, run test compiler is expected to be monadic, despite the fact that it is not. So instead, this is going to be an on left. I guess asset failure would be better than error, come to think of it. Yes, this is not left error. This is from... Actually, how is it called? It's been too long since I've used that one. Data either. Is it from right? No, from right would probably... So from either is probably what I want. You know, from right is what I want. Well, not exactly. I want an either error ID. There we go. That's good. We like those kind of errors. Those are warnings that have become error thanks to W error. And those happen only when there's nothing left to fix. So that's always good. Okay. So all our old tests are passing. There's not a lot of them, but it's still good that they're passing. So now let's add a few more things. So we have here in the integration tests, we have something for the simplification phase. Let's have a look. Interesting. Yeah, okay, I see. What we're doing on this one is we are looking at those files. Like we have the Boolean source here, and we have its simplified version. And we are checking that after passing and applying the simplification phase, those simplify to the same thing. For instance, here B5 does a not of x, which is a Boolean. We are checking that after simplification, it is the same thing as just returning x, which is a Boolean. Okay, so we do have some tests of this phase. What I want to add is first, I want to add some test of the minimization phase. Which will be... Oh, interesting. Oh, because it's using this compile thing. I might want to change this compile module even if it breaks everything, because I think it's not great. Or maybe make changes to it. We'll see. But for now, I think we're not going to be doing things the same way. We probably just want to do like import this directly, not do that, and just write some tests manually here. I do have the autocollect in place, okay. If I look at the syntax in my unit tests I have for this, test group takes a list, otherwise I have test case with a name. Okay. So what are we going to want to do? This is going to be some basic tests of the different rules, I suppose. So if we go back to the minimization here, I have a bunch of rules that are applied. Let's start with merge roles, or maybe test group merge roles. And let's add all of the tests of merge roles here as a big list of tests that we want to try. And what would that be? So merge roles is that thing where we replace subsequent roles into a series of one. So first, we are definitely going to want overloaded lists here to be able to create sequences, because rule is a thing that like transforms an instruction buffer into an instruction buffer, basically. There we go. So we're gonna want to test the rule by like giving it an instruction buffer. So this is gonna be a go, which we're gonna define at some later point. Or maybe just a minimize. Run. There we go. And we are gonna want to express a few of those, and run will be the main thing. So let's try with an easy one at first. I'm gonna need the bytecode here. So let's try something where we have well, maybe not an entrance. Let's say it's at the most trivial case, which is this thing. We have a push of, let's say, 3 and 1 and a roll. Then we have a push of 3, 1 and a roll. We are expecting this to minimize to a push int 3, push int 2, and a roll. Let's check that it does not do it when the things differ. So if we have push 3, 1 roll, push 4, 1 roll, we should have the exact same thing as output. Or rather, we should not have an output. Well, if we run minimize, we will get that. So we should get the exact same thing. So it should remain unchanged. This should also not do anything if there is something in between. For instance, I don't know, a return here. So this should be the same thing in output, despite the fact that there are 2 rolls in a row. Okay. What else do we want to test? Probably 3 of them. If I have a push at a depth of 5, 1 roll, push 5, 1 roll, push 5, 1 roll, this should be simplified to a push 5, 3 roll. Okay. What is run in this case? This is going to be our input output, and this is minimize of the input is the output. Yeah, we don't have to do anything more than that. I'm just going to quickly check which operator it is for this. I'm fairly convinced I have the right one, but let's just check again. Expected value on the left, actual value on the right, or actual value on the left, expected value on the... So actual value on the left is the question mark first. Okay, so that's correct. Okay, so that's tests for this rule. Now let's do tests for the remove rolls. Let's add the trivial case. We have a push 3, 1 roll, push 3, 2 roll. This should be nothing because there's nothing to do. Then let's add a test that's similar, which is we have 3, 1 roll, 4, 1 roll. They should remain the same. Then a test where we could simplify, but there's a return in between, so we don't. And if we have 3 in a row that need to be removed, I'm going to go back to 3, 1, I suppose. Well, I suppose this is testing both merge rolls and remove rolls at the same time. So maybe those tests I am going to actually keep for later. I guess run can just be on its own. Run can be an instruction buffer. Instruction buffer, is that property? I think it's property that I'm looking for. Because this relies on them being merged in the first place. So what I want to test instead is a 3-3 roll becomes nothing. A 3-2 roll remains... Oh, I'm realizing something. We can do better. A 3-2 roll should remain the same. The thing that's going to be broken that I should have realized is a 3-6 roll should also become nothing. And a 3-0 roll should also become nothing. And I don't think those two are true. So we can add tests for this, see that the tests break, and then fix it. Next, what do we want to test? Hello, how are ya? So we have tested the 036 case here. We have the negative test of it does not remove valid rolls. Is there anything else that we want to add? Yeah, doing fine. I'm happy to be back on the project and starting the slow and long process of updating tests and adding tests. Nice. I guess we could do a similar test of testing that if there's multiple of them, they're all properly removed. So perhaps we do this with pushing two like useless roll in a row and then checking that they have been removed. Okay, we remove this. I'm gonna put this run thing at the bottom of the file. Let's say combined for this group. I mean, jumping between programming languages is not the worst. It can be fun. If you like the languages you're jumping like between, of course. Let's just keep this one for now. Let's just try this already. Let's see if those tests are broken the way we expect. It is not broken the way we expect because I have a typo in my pragma. There we go. Yes, that's a problem of copying modules. Property is not the right thing. Okay. So if I look back at, do I have here, what I'm doing is calling that operator here. So I just have to check what the output of this is. It's an assertion, not a property. Yes, yes. If you haven't been there for a bit, around a month ago, before I took a quick break, we are at the point where we are actually compiling some programs. We have generated some basic images. Let me fix this test and then I'll show you. Test group not in scope. That's just... Yeah, I took a long break at the beginning of the year and then a short break at the end of March, which is, but in March, we managed to get to the point where it compiled, which was lovely. Okay, so test group, I thought, is it just in test tasty itself? It might be. Oops. There's still so much work to do, but you know, it's getting there. Okay, so what's wrong here? This needs to be a test tree. So I am using, let's go back to test tasty. I am using a test group, which given a test name and list of test tree. Oh, yes, of course. This run needs to also be a test case. So I need to give a name to all of those. So run needs to take an additional string. And this needs to be a test case with the name of this check. Okay? Oh, and I still have a run here that's no longer required. Which means now all of those cases need a name. And I might start actually aligning it slightly differently so that it's more readable. Remove simple, well, merge simple role. That's the name of the test. This is do not merge roles separated by instruction. The idea is that the IR encodes the like your AST is very low information. It encodes just the thing you have passed. So if you're like you have bugs in the things that you have imported, for instance, a function call doesn't have the right type, all of this, that's still a valid representation as far as the AST is concerned. Your AST can be a valid construction that represents invalid code. So having your IR being a very augmented version that has tons of annotation and cannot, by construction, represent invalid code states, you can have the output of the analysis phase that checks like types and everything be something that represents all of that information, and that would be your IR basically. And you can make it in a way that's a lot like that can be then the idea also is that you have something that's easier to deal with if you have multiple backends. We don't here really, but it's a nice intermediary state of like, okay, we have translated all of this into a lower representation that we can easy like have an easier time generating code from. It's like an intermediate step basically, as the name suggests. This test is, what is this test? We just wrote. Oh, it's this one. I'm wrong. This is do not merge roles of different depth. But I guess if your AST is good enough and no one makes ever any bug in your program and you have enough information in the AST, that might be enough. So, this one is merge multiple roles. Okay, this is, and again, we're expecting some of those tests to break, and that's fine. This is remove simple role. Well, remove empty role. Remove and this is going to be remove simple role depth equals n times steps. And those two expect to be broken because I didn't think of this when I wrote the minimization phase. This is do not remove valid role. And that's remove multiple roles. Finally, merge, then remove as an argument to run. Okay, let's try that. Still not happy. Okay, so this run Oh yes, of course. Now this is no longer an assertion because this is the assertion. This is now a test case or test tree. What's the output of test case? It's not in this file? Fascinating. Why is it not in this file? Oh, it's part of HUnit. Okay, interesting. Ah, I suppose that makes sense. But yes, it is a test tree. Oh, I don't have equality on my instructions. That's interesting. Let's go have a look at the bytecode. I do indeed do not have equality for this. I think that doesn't hurt at all to have it. So I think it's fine to just add equality there. Because address is just name and label. Those have equality, I'm fairly certain. And when it's resolved, it's void, which trivially passes the equality, and unit, which also trivially passes the equality check for different reasons. Let's see. Well, it's more that like you could just have your AST annotated with type information. That would also be fine, which is in part what I do. The AR is just a representation that allows you, that's, as the name suggests, in between the very abstract AST and the very practical like code down the line. And this first transformation, it's easier to do the transformation in step by step through like say intermediary languages than directly generating code from the AST to the thing. Well, it's usually easier, and also the upside of this intermediary representation is if you have multiple backends. For instance, here a thing we want to do, I haven't done yet, is use the LLVM backend to export our IR into the LLVM IR and compile our programs into actual binaries to compare with the Piètre version. And so having something that's much closer to what the LLVM IR is makes generating that a lot easier than if I were trying to generate it from the AST. So I lower into an IR, which is a much, much simpler representation of the code, very like almost close to a bytecode thing at this point. And from then I can fork to the LLVM IR if I want, or do code generation towards my bytecode. To give you an idea, let me show you something. If I go here, this is the last time I compiled this thing. I have here a representation of the AST after it's being passed and annotated, like of a piece of code after it's been passed and annotated. If I look at the test file here, it's this one. Yeah. So this is a piece of code in our language. Does a write int of an int here, write int of an int here, write a character, write int of the call of the Fibo function with read int as an argument. Foo and bar do nothing. They were just here to test the pruning of the thing. And here's a Fibonacci function written as a while loop because I was testing while loop. Originally, it was written as a recursive function. And in fact, I can probably just remove this case here, but that's a thing for later. So this code, this preview of the AST it has all of the annotations, so I can check like, oh, this current here is the same as this current here, which is the same as this current here, which is the same as this current here. This n is the same as this one. When I called write int, it has been resolved to being prelude write int. When I call this variable function, it has been resolved to being that one. Like all of those things have been checked and validated, and our AST is still basically the same thing, but with a ton of annotations that are not present there that have checked the types and added the information and adding like exact symbol names and so on. By comparison, this is our IR, which represents all of the operations as a series of extremely basic instructions that assign values to write write once registers, basically. So here we assign this value to register 0, then we assign this value to register 1, then we write int with register 0 and register 1. An optimization phase on the IR could realize that those registers are the same and deduplicate them, but we don't have that for now. And like you can see how like we assign values to registers and then call functions, and that's about it. And here our Fibonacci function is decomposed into like almost like very basic things of we assign values to registers. Like we have register 1, which is 0, and register 2 is the comparison for equality between register 0 and register 1. Then we do a branch based on the result. If it's true, we go to this part of the code. So you see there's already been a pretty strong transformation between the annotated AST and the IR. And this version of the code is still not, it's still not the same thing as actual Piètre code or bytecode or anything, but this representation is somewhere in between, as the name suggests, the AST and the actual bytecode. But it's simple enough that we can like it makes generating code fairly straightforward. For most of those operations, it's going to be like 1 or 2 or 3 like actual Piètre instructions, but it's still like abstract enough that we can do things such as optimizations that we don't do yet. And also, since it's intermediary again, I can have multiple backends. I'll have my Piètre backend, but I will also have at some point the export to the LLVM IR backend, which is like somewhat similar to this logic as well. And what's missing here? Oh, there's a thing missing. What's missing? Push address doesn't have. What does that mean? Oh, that's because I have the show constraint here. I don't have the equality constraint here. That's what it is. There we go. Okay. This means recompiling a bunch of things. That's fine. Okay, that's the good kind of errors. So now we're expecting the sum of the remove tests to fail. Yep, there we go. Oh, the 0 case worked. Okay, I didn't remember that one worked, but the multiple steps doesn't work. Okay, as expected. So that's good. The tests that we wanted to pass are passing. The test that we wanted to fail is failing. That's always good. Okay, so let me just go back to this little program. Let me actually compile it. There is a warning because I have an unexpected top-level expression. It's this 42 here. And in fact, if I regenerate the IR you'll see that here I have this thing that just assigns 42 to a register and just returns afterwards and do nothing else. And if we look at this version, yeah, that's this 42 here. And if we look at the generated code, like actual Pete instructions, for bar, we do a push int 42 followed by a pop. So we do something that's completely useless. Hopefully that means like we should have, I don't want to write this as a minimization rule because we should just be avoiding code that does stuff like this in the first place. But if we look at the linked version, it should not be there because the linker removes foo and bar because they are unused. And the result of this program is here as program.png somewhere. 23rd of April, is that today? That is today, so that's perfect. And if we run that one with program and npit, so it prints the value twice that was in the main, I was testing something. If I give it 10, I get 55, which I believe is correct. That's probably correct. It's one of those. And the program looks like, I'm going to open the current one. It looks like this. That is our Pete program that we just compiled. So you can see here at the top, this big like thing is our address selection. Whenever I push an address at the top of the stack, this thing decides where we go. So if we're going to address 1, which is this is address 2, this is address 3, this is 4, this is 5, 6, and so on. So what this does is check that we are less than the next threshold and remove, like, are we less than 2, so 0 or 1? If yes, this instruction here makes us go this way. Otherwise, we subtract 2 from the thing to have like -2. Then we check, are we less than whatever, how many entries are there? And this addressing system like points us to the right function, basically. Wait, am I on the wrong commit? Oh no, it's fine. No, this is the small functions. This is read int, write int, and so on. I thought for a second that foo and bar were still in the linker. They should not be there. Because indeed, foo and bar are not there. I really like this big rainbow thing. Those are the big numbers, because since a push instruction pushes the number of pixels in the last group, if I'm pushing like 30,000 on the stack, I would require a block of pixels of a size 30,000, and I don't want to do that. So big numbers are divided as multiples of 16. And so this is how to add to the stack that value that we saw in the code, this one. That's what it looks like. And given that push in and multiply instructions are like fairly regular shifts in hue, we have this very nice like rainbow pattern whenever we do that, which is pretty nice. So yeah, that's our first program, and it has even some built-in functions like write character, write int, read int, and so on. So yeah, we're getting to a point where we have something that's working. Of course, there's so much that's missing. Structs are missing, lists are missing, strings are missing. Like we can do ints and maybe booleans, and that's about it. And I even made some stuff with the way the read int is working. The spec of Pete is absolutely horrible for this, so I might need to actually never use the actual read int of Pete, but make a read int built-in that actually use the read character function of Pete, because the read int is absolutely monstrous. Specifically, but we're getting in the weeds there, the read int instruction, if no input is waiting, this is an error and the command is ignored. Which means instead of telling me, oh, -1, we try to read something that doesn't exist, it doesn't change the stack. Which means that the size of my stack depends on whether the in command worked or not. So, oh, I'm not gonna do anything too complicated because, you know, it's Pete underneath. Since Pete doesn't have a heap, I am extremely limited in how I'm doing strings. So what I'm gonna do, I think, the plan is to have a string just being a series of characters on the stack, basically, preceded by a cell on the stack that gives me the size of the string. The big difficulty there is if I go back to my code generation, here, a lot of the things here that look at the IR and generate actual Pete instructions, like here for the branch, for instance, and for the returns and so on, for things like, well, I have a function call and I need the arguments to the function to be on top of the stack. I have some helpers here in this file, like generate, rearrange stack, and so on, that like give me a bunch of instruction buffer to like create something that rearranges the stack using this thing here. All of these functions for now assume that every single register as defined in the IR, so those things here when I'm saying like, oh, register 0 is this value, register 1 is this value, register 2 is this character, and so on. So far, this code assumes that every register is of size 1, one cell of the stack. So a push will always add one cell, and a value is always one cell of the stack. This is simply not true because structs will be multiple cells for one register, and lists will be a dynamic amount of cells for one register, which means all of those, rather than just being like, oh, there's 3 things on the stack, we rotate by 3, will need to dynamically compute the amount of the rotation of the stack by iterating through the stack to look at the size of the things that are on top of it. This is going to be extremely complicated, and I am not touching that this evening. So yeah, we have some stuff working, but we have so much left that's not working yet. Hence, at the moment, writing a big test harness so that when I start doing some of the very complicated stuff around code generation for multiple registers and so on, when I start doing that, I want to have as many tests as I can to ensure that I'm not breaking anything. So we've added some tests for the remove simple role, and there is one case that we are not handling correctly. Let's go back to the minimization phase. Not this one, the other minimization module. There we go. And remove roles. There we go. Here I have steps equal 0 or steps equal depth. And I think I'm going to change that to say that steps modulo depth equals 0. Which means basically we are rotating things to put them back in place. If I change that, now all the tests should pass. Yep, there we go. There's also a thing I want to change. Apply on all prefixes, apply on all suffixes is an absolutely horrible name. What this should be called is apply on leftmost. And this is apply on rightmost. All prefixes to leftmost and all suffixes to rightmost. There we go. There's something I'd like to test afterwards, But let's for now continue adding tests to the minimization. If I look at this, we've added tests for merge and for remove. Reorganize stack, what's that again? This is another case of this is not written very well and I can rewrite this. Because this is, oh, I have as many pushes as I have a roll. No, this is correct. Okay. Although the code is not very readable, I could have done better, I think. Since this is returning a maybe, I could use the fact that the maybe monad on fail just does nothing. Does sequence have a way to do like, can I get a maybe value out of this? Like pop head or something. I guess I can just make it. I can just do a pattern that fails. Yeah, that's probably fine. This can probably be rewritten as let left hand side, right hand side do a span L is push of S. And then I decompose that into push is followed by push int depth followed by push int steps. Actually, I could just go even further and just do that. Wait, no, that's not correct. Is it correct? That would be if I do a view R on this. Is there a pattern that I'm trying? Okay, there is a pattern. So this would be this. There we go. That's not very elegant. I think this is actually worse. I think this is worse. I'm just gonna leave it the way it was. Okay. But yeah, what this does is we have a bunch of pushes of int of addresses followed by a roll, the depth of which is at most the number of pushes. If that's the case, we can rewrite this to remove the roll altogether, basically. So let's add some tests for that. So this is reorganize stack. simple case. The simple case is we are pushing 1, 2, and 3, and then we are doing a push 3, push 2 roll, and that's the same thing as directly doing. So 1 becomes last, so it becomes 2, 3, 1. Okay. We should not be doing anything, however. Reorganize simple stack. We should not be doing anything if the depth is greater than the size here. So if we have, let's say, a return, or let's have a look at the other bytecode stuff. Let's say we have a duplicate and an in character. So we have an in character and a duplicate. And then we have those 3 things. Actually, in fact, let's put them here as well. There we go. Now, if we have this, but the depth of the roll goes past the pushes, and let's go, let's say that's 4, then we cannot reorganize things. Well, I guess we could, but this is more complicated than what this rule is able to do. Do not reorganize stacks containing non-pushes. What else do we want to do here? Oh, I want to also, here I probably want to add another test. I want to make this probably, let's say, 4 here. Because since I've used the modulo, I want to make sure that I don't remove a thing when the modulo is the wrong way around. To be consistent, I could use 6 and 3 since I've been using that on the others. Okay. Okay, so that should be it. Let's also add something like this, where indeed we have additional pushes behind. So let's say push. Oh, we should probably also test with address. There we go. And now this is a roll of 3. So only those 3 last values should be impacted. Actually, I don't want to use 0 here. I should be using, let's say, 8 and 9 so I can differentiate them. This should become 2, 3, 1. But those 8 and 9 should remain undisturbed. And we can add another test that we also mix and match properly with addresses. So let's replace this push into with a push of an address. What is a push of an address? It's something that at this phase contains an address, which is a mix of a name and a label. where some address is gonna be some name and a label there. So this should be the some address. This should be some address. There we go. How do we make an arbitrary address? Do I have... I'm not in main. I'm not in IO here, so I can't easily do... I can't easily generate arbitrary addresses, even if my arbitrary thing has addresses. I don't know if it does. If I have name here. I don't seem to know. So let's just make up one randomly. What's a name? A name is a base name, which is a module name and identifier, and a bunch of parameters. Okay. So this is going to be a base name with some stuff and some parameters that I don't care about. The module name is itself a non-empty list, if I remember correctly. Of identifiers, yep, that's fine. I have overloaded list, so this can just be main. And the actual name of the thing is just an identifier, and let's say foo. There we go. That should be a name, and the label is, I believe, at this point, not much more than just an int that's defined in the IR. It's a, oh yes, 2 ints, block and inner. So let's, for now, say, let's 1, 0 something. 1, 2, there we go. Okay, let's test this reorganize stack thing. Ooh. Tasty autocollect failed in phase. That's fascinating. So that means that I have something that's not saved properly. Yep. I don't know what I've changed, but it wasn't saved properly. There we go. Oh, thank you. So, what do we have that's broken here? Oh, I have a run here that's just... Name is not in scope. I need to bring name into scope. Do I need... I will need the IR as well for the label. Ambiguous, of course, yep. So let's just import label, because I don't want to import things that conflict between the IR and the bytecode. There we go. All tests passed. We love this. Minimization, reorganize stack, simple stack, do not reorganize stacks containing non-pushes. That seems to have worked. Oh, except this is still called reorganize simple stack. Stack with addresses. There we go. Next. What's the next thing that we need to add tests for? I should also mention this. A big part of this project was no code is written outside of the streams. So yes, some streams are gonna be just writing a bunch of tests, but a huge part of this thing is none of the code has been written off stream. You can go and watch the YouTube history of everything we've done except for like the one stream that we lost. But like no code is ever written out of stream. So all the cleanups, all the tests, that's also it's less interesting perhaps than like the actual new features, but it to be consistent, it's all written here. So next, we've done tests for merge roles, remove roles, reorganize stack, remove redundant jumps. Oh yeah, that's interesting. Let's do that because that's a pretty trivial one. So let's do that. Remove redundant. Do I have redundant? Jumps. Remove simple jump. So this is a thing where we have some kind of operation before we have a multiply, let's say. And then we push an address. Let's use the sum address for now. Let's say I'm gonna need multiple addresses. How do I name them is the thing. I might name them with the full thing. So this is main foo12. So we are pushing the address main foo12. And then we're doing a return, which goes back, if you remember the way the thing is implemented, like exits the current function, goes back to the address selector and decides where we go next. And then we have the entrance main foo12. If we have that, then pushing the address to do a return, to do all of this, to just go there is useless. Actually, let me check something. Yes, we do the thing correctly. This can be replaced by the code that was there before, so the multiply, and then just the entrance main foo12. We can't remove it necessarily because it might also be the target of another push address return somewhere else. But when we are pushing the address and return, we're just jumping from this multiply to this entrance, so this thing can be removed. The multiply is just there to make sure that we don't delete things on the left-hand side by mistake. Let's try. Oh, I should have also added. Let's add one here. Let's make sure that this is applied more than once, like if it appears more than once. So if I have this push 1, 2, 3, push 3 to roll, and I have it twice, I should get those pushes twice like this, to make sure that the rules are not applied once. So let's let's do the same thing here. I have I'm gonna duplicate this and duplicate this. Make sure that this rule is not applied just well. That means having two entrances with the same label. I don't like this. Let's introduce main foo22, let's say. Now, something I need to check. Yeah, we have a removed unused entrances. Yes, that's something that bothers me. I think this test is going to be broken by the fact that our optimization to remove unused entrances will kick in and be like, oh, this entrance is never used. We can just remove it. And this will actually return multiply. Let's test this to check that this assumption I'm making here is correct. So the test should fail. Yep, they do. We just get the multiply, we just get multiply, multiply, because the entrance is being removed by our optimization. Okay, so that means that we need to make sure those addresses are used, even if it makes no sense. So let's try something like entrance with main foo 0, 0. And then let's have a push address of this. So it's used somewhere, a multiply, which is nonsensical, but that's fine. And then the thing that we want to test. We should have that. Which means I can do something similar here. I can just push those two addresses on the stack and then multiply them, which is nonsensical, but this guarantees that they are used. And therefore that another optimization will not kick in. Okay. That makes this particular test a bit more verbose. I don't like this that much, but okay, now this works. I suppose we also want the negative test of do not remove valid jumps. So let's go back to this simple case, I suppose, where I have a push address of 1, 2 still. And then I push address 2, 2, and I return, and I have then the entrance 1, 2. This is going to a different place than this, so this should not be optimized. Therefore, this should be left exactly as is afterwards. Okay. Next, what do we want to do? Well, next is the remove unused entrances. Let's try that. Let's start with the negative test. Do not remove first entrance, because every function starts with an entrance, and that's the entry point for external colors of a function. all of the other entrances within the function are for jumps within the function. So those, if they are not used, can be removed. But the first one should always be kept because it is where the function like is called basically. So if this is a normal function that does, I don't know, a push int 4 and a multiply and a return, which is a function that given an argument multiplies it by 4 basically. So this assumes that there's an argument on the stack. This function should be left exactly the same. Do not remove an entrance. I want to test an entrance that's jumped to before or after, I think. So this would be, I have my entrance here, and then I have some kind of let's look at the bytecode. I want a branch, I think. Yeah, I want a branch, not a return. That would make more sense. So let's do, I don't know, a push address of main foo12. Oh, I could probably do that with branch as well. Yeah, I could probably do that with branch. Because if I'm branching on something... No, it's more complicated. But that's probably another simplification I can make. Okay. Okay, I'll do that after doing this. Because I probably want to do some kind of here. I push the address, and then I do a push of an int 1, and then I do a branch or something, which is an unconditional branch. It's kind of useless. And then I have my entrance. I should probably do something else. Because I will probably want to optimize that as well. Let's do something that's nonsensical, but that's fine. Let's do a roll. This doesn't have to make sense. And here just return, I suppose. That's fine. But now we have a push address of this. We have something that jumps to it. And then we have the entrance, but not something that can be simplified away. Well, not yet. Well, I guess this could be simplified. It's hard to find things that... Let's add a multiply here. There we go. It's nonsensical, but... Oops, this should be here. And now let's have a thing that's just... We have this. Let's just do... Let's make it somewhat consistent. It doesn't matter. It doesn't matter. We have this entrance and a return, despite the fact that this will just, like, this is dead code, basically. But as far as this optimization is concerned, Ah, god damn it. As far as this optimization is concerned, this is fine because this entrance is used. Okay. Okay, let's test that. Something I need to check is I never remember if my branch is a branch on 0 or a branch on non-zero. I think it's a branch on 0. Okay. Let's have a look at the code generation just to make sure. Generate branch. I don't remember. Okay, but this is pushing the address. So we branch if it's full. So we're branching on 0. Yeah, okay. We are branching on 0. Okay, so let's duplicate this group. And let's change. What does a branch look like? As we've seen here, a branch is pushing the address, doing a swap, and then branch. Can we simplify this? Yeah, we can. If this branch is going to somewhere that's useless, we can remove pushing the address, doing the swap. We can just pop the value altogether if we are always branching immediately to a place we're always going to anyway. Okay. Downside is this forces us to hard code some of this in the test, but it's worth it, I think. So let's add a test for it, and then let's add a rule for it. So here, this would be a case of we're pushing an address, and then we're I can't type. Push int to push int one roll. Right. Wait, what am I doing? No, yeah, that's good, that's correct. So we have a push. Oh wait, but otherwise, if it's gonna be removed altogether. Yes, that's why I had this extra push address multiply thing. Let's keep that. So if I have pushing of an address, then a swap, which is push to push from a roll, then a branch a pop and said address, this can be replaced by do not push the address, do not do a roll, immediately go to the entrance. So here it's the same thing. If I have push of an address followed by, instead of a return, it is push to, it's all of that. That's going to be a very verbose test. I might want to break it into multiple lines. Oh, I can remove this. Yeah, multiply here, I think. Wait, why do I have this multiply here? Oh yeah, I'm just going to do it this way. There we go. Okay. And that is replaced by here, all of this push to push one roll branch pop should be replaced by, oh, the condition still needs to be popped. So it should just be pop, and so here I probably want to add a random instruction here. Let's say, oh, I need to be very careful. Let's say in, what's the bytecode? In int, because I'll have to be very careful. I cannot just be like, oh, this can be removed because we are doing pop of the thing that's just being processed, because this is something that performs side effects. So the only thing that we can remove would be a push. The pop will have to stay otherwise. And here, since we're doing a push address, I need to do the same thing. I need to do an in int, or let's say an int character. Before the push address. Okay. Let's also break this one down so it's more readable. This one is okay. And here, this is a case of we replace this return by all of that. It should remain the same. Okay. So now those tests are gonna fail because we did not implement this. And we are probably going to want to also add immediately another test group. Remove push pop. And that's going to be a separate step from this. This is going to be a very simple thing of remove push pop, where if we have a push int 1 followed by a pop, we are expecting this to be replaced with nothing. If we have multiple in a row, we want to check that the rules are applied multiple times. And if we have nested ones, they should also be removed properly. So if I have push int 1, push int 2, pop, pop, we should still have 0. That one is tricky. I kind of want to make a thing where, like, if the stack is not modified, like I do a push 1, push 2, multiply, pop, that's the same thing as not doing anything, but that requires testing a lot more. That's a lot more complex. But that should have been taken care of by the optimizer anyway. The optimizer will guarantee that, like, push int, multiply, pop will never happen anyway. In theory. So I don't think there's a need to actually do that at this level. This is mostly to take care of other simplification phases. So I don't think we need to test very complicated things. We can probably just test a push int 1, push int 2, push address main foo 1, 2 return pop or something, which is perfectly valid. And we just check that it's not removed. There we go. So now a lot of this will not work, and we can go back and add some new rules based on the things we have discovered we could do. Yep. Go. let's see what breaks. We should have all the branch tests failing. Yep. Do not remove valley jumps. Yes, this test passes because we're not removing anything. And the push pops we do not handle yet. Okay. So now that we have the tests that are failing, we can go back to the actual phase and add remove redundant jumps is not going to be returns, and this is going to be branches. And we will also remove push pop. So remove redundant jumps is now returns. We can add the same thing for remove redundant branches. This is going to be a bit more because this is going to be, we have a push of an address, then we have a push one, push two, push one roll, and then we have the entrance, and we have a pop. Rather, we have the pop, and then we have the address. And here that's 1, 2, 3, 4, 5, 6. And in the case where the address here is the same as the address here, this becomes just pop and go to the entrance. But the thing is, yeah, this makes the computation before unnecessary. So maybe we want to remove. Maybe we want to remove. Maybe our remove push pop should be a lot more. Like if we have a branch in the code and it's based on a value that's never used, but I think it's going to be very rare that we can confidently remove the value being created. The only case where we can confidently remove the value being created is, again, a push. And anything more complicated than that, as something that has a multiply or something like this, either involves values that have been obtained by side effects or by function calls or something like this that we cannot guarantee are without side effects, so therefore we cannot remove them. So I think no, actually, I'm convinced our push pop needs to be minimal. Okay. So remove push pop. Oops. Let's put it here. That's a very simple case of we have push of an address A followed by a pop. We can replace that by just nothing. If we have push int followed by a pop, we can replace that with nothing. Okay. Now let's check that the tests that we have written pass with those new changes. This is a push int. This is a push int. Okay. Ooh. So for the branches, we're wrong. The push pop, the test pass, that's not that surprising. So what do we have here? So that's remove simple jumps in the case of branches. So we expected entrance name foo00 push address. Oh god, it's monstrous. Okay. Multiply in character pop entrance. Yes, in character pop entrance. But instead we got... Let's put this side by side so I can see what's happening. If this were a tiny bit less zoomed in, that would be a tiny bit easier, but it would also be harder to read on the stream, which is why I don't do it this way. Where does this diverges? This is all the same so far. Oh, the push address is still there. So the rule did not apply properly. Yeah, we still have the push to push in roll branch pop. Okay, so the rule did not apply properly. Oh, because I'm missing the branch. There we go. Okay, we have one test failing. That's probably the way I have expressed the test there. Let's see. Oh yeah, I probably want to add... Yeah, because here I had the push followed by a pop here. So the combination of both would remove everything. Okay, so if I add a multiply the same way I do here, I should prevent this from being from also triggering the second rule, and now everything should be the way I expect. Oh, but I need to add it to the here as well. Oops. Oh, damn it. There you go. Fixed. Aha. Now this is getting interesting. I should really make a... I really should make a show instance for names that's a bit better. Because this is always completely unreadable. Let's do that as a side thing, just to make all of this nonsense more readable. Okay, let's go to name. And let's make an instance of show. The thing is, the idea of show is it's kind of like the debug of Rust. It prints something that can be read back or pasted in GHCA. Like it prints a Haskell representation of the value. What I want to do is use the fact that with the overloaded strings and overloaded lists extensions, it's possible to create a name without specifying all the constructors, which is going to make it a lot more readable. So show of a base name with a module name and an identifier is going to be base name plus show to list actually yeah, module name plus show identifier. Okay. Which I'm tempted to write as a concat and do this line by line. There we go. And name is going to be somewhat similar. This is going to be name with between parentheses show of actually this one can keep its base show instance, I think, because it will do the right thing of name showing the base name, showing the types. So this one can keep its derived show instance. And the only thing is, I'm going to go to identifier, and I'm going to change this to be deriving show via text. Which should make the error here a lot more readable and hopefully won't break any other test. It might break some other test. That'd be fun. I doubt so. However, yeah, it forces us to recompile everything. So now we wait. Okay. So that should be a tiny bit more readable. Oh, but it still shows name, name, base, and so on. So I probably want to change that. So I probably want to add, sadly, that means recompiling everything. I probably want to have a custom show for name as well. Name, base, name, params is name. Between the parentheses, show of the base name. And then show of the params. There we go. This is just purely a cosmetic change. It should still allow, like, respect the law, the unofficial law of show that I should be able to copy paste the output in GHCI and get a valid value of type name. It will just require overloaded lists and overloaded strings to be enabled, but that's fine. The parser is so slow to compile. Okay, let's see. Now we should have a much more readable error message. I forgot to do the same thing for the label. Okay. But now our entrance is the name, base name, main foo with no type. That's a lot more readable. So now we can probably just rewrite the show instance for label, and then we have really something that's more readable. So that's going back to the IR, and this means I want to do an instance show of label where show of a label with two blocks, two values b and I is gonna be label. I'm gonna do as no, it's fine. I can just do it in one inline. Show b plus show I. There we go. Still recompiling a bunch of things, but hopefully a bit less. Still a lot. Okay. Okay, so now label tutu. That's a lot more readable. So now we have this whole thing has become name, base name, main food, no types, label tutu. That's a lot more readable, and it all fits on one line. So now the error. We're trying to fix is remove simple jumps in the case of a branch. It's this one. So we are expecting. Oh yeah, I do have an int here that's just not there at all. Why am I expecting that? Oh, this is because I wanted to avoid the case of having something that then triggers the push pop. So I guess this is just I need to add an int in both of those cases. Yep, that's what it is. And if I compare here, it's the same until multiply pop the int is missing here, and pop the int is missing here. That's what it is. Okay. Now I think that's all of the tests. That's all of the rules, I think. No, we didn't do push by duplicate. So let's do that quickly. We have push int with a large number. We have push int with a large number. We expect this to be replaced by push int and duplicate. Oh. We didn't add a test for, we didn't do this for address as well, which we should completely do as well. Okay, we should probably test that it's applied multiple times. And I guess I can just do it once with both. It's gonna be easier. So I have, let's say, 4 of those, followed by 3 of those. We should return a bunch of duplicate here, followed by 1 of those addresses, and 2 duplicate. There we go. I don't think I need to do a negative test here, just because we have already so much coverage of the rest of the rules. So I don't think there's like complicated things I need to do here to just check that it's not. I could just add a very simple one. So if we push 2 ints that are different, even if we push the same int afterwards, we should not be deduplicating. There we go. That should be enough. Okay. And now that should be all of the rules. So now can we do a combine one that tests all of the rules at the same time? Maybe not, but we can probably do something that remove jump, then push pop, and unused entrance, I suppose. And can we go further? Oh, oh. We want to replace push pop before we replace push by duplicate. So that if we have push X, pop, we don't do push X duplicate pop. I guess we could just also. I guess we could just also. It doesn't matter. Where is push pop? I guess we can also just replace duplicate pop with nothing. Because that's just doing nothing. So So now if we do this and then we do a duplicate push int to duplicate pop, 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 pop. Duplicate pop should be removed. Push to int pop should be removed. Duplicate pop should be removed. So it should still be 0 at the end. Okay. let's try it just with this at first. So let's say we have a push of an address main foo 1 2 followed by a return. Let's move a branch actually. We push an address, then we do a push int one roll branch pop entrance main foo 1 2. This should all be removed except for the entrance. Except the entrance itself is unused, so should be removed. The pop will be kept. If the condition is a push int 1, then we are going to end up with a push int 1 and a pop that's also going to be removed. So maybe we can do something where we have push int 5, push address, push int 5, push int 4, push int 2, push int 1 roll, which will be reorganize. So this is going to be the reorganize. This is going to be replaced into a push int 4, push int 5. Then the pop is going to... So if I just add another pop here, this should just all be entirely removed. Because this jump is not required. Therefore, it's all replaced by a pop. The entrance is unused and will be removed. And so we're going to have just stack manipulation followed by 2 pops that are just going to cancel one another. So that should test the combination of multiple rules at the same time. Except I just need... I'm half tempted to make those like actually top level. Doesn't make a big difference. Let's see. Okay. Oh, what do I have? The duplicate simple push address. Yes, that's the whole point that we are testing that this is now a duplicate. And indeed, I got push address duplicate, which is what we should have obtained. Okay. Oh, so we still get some stuff. Interesting. Oh, I understand. That makes sense. I think. Let me check here. Yep, I see what happened. This is a problem of the order in which the rules apply. So this is a good test. The problem here being that this thing, like this first one is reorganized, so it becomes a push 4, push 5, which means this thing becomes push 4, push 5, push address, push 2, push 1 roll. And as a result, this push 2, push 1 roll is removed. But we do our pattern matching of a branch on this because this is how a branch is implemented. Which means that if we want this to work, we need to go back here. This is why having the multiple things at the same time is useful. remove redundant returns and branches needs to come first. Okay, and now this works as expected. Okay. Okay, that's not too bad. At least we have some like confidence that the rules that we have added for minimization are better. And most importantly, by adding tests, we figured out a bunch of things we could have been doing better. So we've added a bunch of rules. So that's pretty good. Out of curiosity, let me run a stack test coverage. This is going to be very slow. So while this happens, I'm just going to commit what we've done. So first, let's commit that on its own. Then yep, there it is. Okay. That's not. I guess it's mostly name. Add custom show instances for readability. Then I guess fix tests, fix compilation of old tests. And then, well, no. Well, actually, no, let's add the tests first. Because the API hasn't changed. Here we haven't changed the API, we've just changed the rules. So this would be test add integration test for the minimization phase. And then add new rules. For branches and push pops. There we go. Okay, so in the meantime, the coverage report 4. Let's have a look at this. The total is going to be 47% is better than I thought, to be honest. I'm surprised. It's much better than I thought, to be honest. Is it because, yeah, I think this is 47% of the modules. I think a lot of modules are just never tested. I think that's the problem. I have to figure out how to make sure that all the modules, even the ones that are not included at all, because I'm looking here at the stages and we have the analysis. That's good. We have the parsing, we have the minimization. and we have a simplification, but we don't have anything that's testing the rest. So of the modules tested, we have a 47% coverage or something. That's not great, but we knew that already, so that's not bad news. That's just confirmation of what we knew. But if we look at minimization, that's the test one. I want the stages one. Where are you? Stages minimization. Let's see. Oh, we don't test remove push pop with push address. Interesting. Always true? That means we don't have a negative test for remove unused entrances. Interesting. Is that correct? Yeah, we don't test for push address. That's a good point. So let's just add that, I suppose. And let's do that as well here. That way we're testing that we are doing all of them properly. Okay. And now we never remove. No, we do have a test for this. Do not remove a used entrance jump before, jump after. So why does it claim? Ah, I see. Because here we have a line that says, let me zoom this so it's readable on stream. If the set of unused addresses is nothing, then we don't even do the filter. We just return nothing. So like, oh, there's nothing to do, basically. Otherwise, we do the filter. But as a result, since we never test a situation where we have an entrance that must be kept, an entrance that must be removed, this line of code is always true. So, to make sure that we test everything, we can add a only remove unused entrance. So let's copy this one. I think it makes more sense. And then let's add another entrance here, which is gonna be, well, not in the output, I suppose. Which I say is gonna be 1, 3. There we go. Okay, so now that should cover the things we have forgotten to cover. What change that forces everything to recompile? Not much. Weird. Oh, it recompiles because I'm rerunning it as test without coverage. So let's kill the compilation. God damn it. There we go. And rerun the one with coverage here, which means recompiling again, but that's fine. That's my fault for not realizing earlier. I'm thinking about looking at the coverage as well. For the internal compiler error stuff, where is it? We have 0 coverage. To the point that, like, oh, it's because we are recompiling the thing. And I think that's fine. In the sense that, like, testing for internal compiler errors is going to be difficult. Because in theory, if for valid inputs to a phase, there should never be an internal compiler error. That's the very definition of it. So I guess we could try to craft invalid inputs to some phases and make sure that they are rejected with an internal compiler error. But it might not always be possible for all the phases to. It might not always be possible for all phases to find a way to express invalid input, because a lot of things are valid by construction, and therefore it might not be possible to test most of the internal compiler errors. Hopefully. What am I missing? Conflicting definitions, because I did not rename it here properly. Okay, tests are passing. Assuming it's going to be in the same place. It is. Let's go look at the minimization now. It is 100% covered. And now we have fixed the 2 remaining issues. Nice, okay. Out of curiosity, let's look at simplification, because we have some very basic tests for the simplification phase. Ooh, there's a lot we don't cover. Ah, but that's because we never cover negative tests where we don't do anything, I think. No, if for while let things could be simplified in them, and we have only simplified on return so far. So if, else, for, while, let are not. Okay. Lists, yeah, that's fine. Ooh, we didn't test the division by 1. Yeah, we have a lot of things that are not covered by the tests. So let's have a look at that. Okay. So that just means that I need to add more cases in here. So boolean.source, for instance. I have tests for and true, but I don't have tests for or false, basically. So I guess I could duplicate those. Or maybe, let's write it as boolean and only keep that. Write this as boolean or at source and keep that, because we are looking at source files. Okay. So if I look at the boolean simplified, I should write this as boolean and simplified and only keep those. Is it from 4 onwards? Yep. And now I can also write this as being the boolean or simplified. And here we want to test true or x, false and x, x and false, x and true, x and false. The simplified version being true or x is always x, true, false. Wait, no, true or x is always true. Right? Yep, that seems to be the case. Of how it's implemented, at least. False or x is always just x. X or true is always true. And x or false. Why don't we simplify? Why don't we simplify this one? Is it because... Yes, of course, we can't remove the call to x even if we know, because of short-circuiting. So here, this would still be x and true, because this x might be some form of side effect thing. Like it could be a function call or something like this. And we need to be able to guarantee that we don't remove that. So the rule doesn't apply for the left-hand side. Yeah. Either x or false is just x. Okay. Now let's add on this or if I have a function who takes a boolean and returns a boolean and just returns x and does nothing else. I should be able to replace all of those x's. It's fine. I don't need to do that. It's good enough like this. Okay. So that's our boolean or. The boolean and should be the same as it already was, which means I can go back to the boolean source. And what do we have here? We have... So let's rewrite this as boolean EQ. source, Boolean simplified. Let's rewrite this as Boolean EQ simplified. And in this, we are going to remove everything up to including B5. I'm not going to fix the numbers. I think that's fine. And I guess the last thing is the Boolean source is now just this one. Boolean simplified is now just this one. And I can go here and I can rename it to, is it rename? This is now Boolean not simplified, and this is Boolean not dot source. Okay, so now we should have added coverage for a bunch of those. Let's have a look at arithmetic source. What do we do? Oh, we don't do the divided by one. Divided by one is here. Why does it not trigger here? It should. Because this addition... Oh, the problem... I know the problem. The problem is, since this doesn't contain a value, an x value, the constant unfolding happens before simplification, and as a result, none of this actually happens. So we need to introduce an x here, and this should be x now. That should cover the division. We did not cover the true and true equals right-hand side in the Boolean equality. Oh yeah, we didn't. Okay. Okay. So now let's have a look at our thing. So now the test should... Oh, no, 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 no. I want to run it here since I want to run with coverage. Hopefully it didn't go too far and it didn't remove all the cache. I did. No. Okay. No. Okay. Oof. Oof. Okay. The tests are still passing. And now if we look at simplification, we have arithmetic, boolean, and or not equal. Perfect. And now if I refresh this, now everything here is covered. Perfect. Now that means that if I want to cover everything, I need to have something that has more diverse statements. So let's add another file here. Let's do, what do we want to do? Let's do a combined source. And let's have a function foo that takes a an int and b a boolean and returns some kind of int, I suppose. And we can do a while b, or rather, well, b equals true, let's say. Is it, what's the, yeah. Well, b equals true. If a plus 0 is less than 5, what else do we need to do? We need a let. We need an else. Else if a greater than 8, else. So we need to try all of them. And I guess those are not important. This can be a return. This can be a return. Here we can try with let x equal, calling the same function foo again. I need a for loop. I don't have a for loop yet. Foo again with a and b just the same. It's useless, but that's fine. And here we need a for x in 0 to 5 return or something like this, to make sure that we try to simplify every branch. Now, let's the simplified version should not be a lot different, but b equals true should just be b, a plus 0 should just be a, and nothing else should have changed, but at least now we should cover. Let's put here some, those returns are wrong. So let's try a divided by 1, and I don't know, x divided by 1. I need a return here. Oh, I need something in here as well, so let's try not the boolean. Return a is fine here. We've already tested within a return. We've tested something within a for, within a while, within a let, within an if, within an else if, within an else. So we should have tested replacing things in all of those cases. What are we forgetting? Expression statements. Expression statements, okay. And I guess continue and break. So here I can add a continue. Here I can add a break. And I need an expression statement, which will be just foo of a times 1 false, let's say. There we go. that should cover everything. While b equals true becomes while b, a plus 0 becomes a, not b becomes b, x divided by 1 becomes x, and a times 1 becomes a. Let's see if this works. Oh, interesting. It did not pick up on the fact that there's a new file. That makes sense, because it didn't... That makes sense. Since template Haskell didn't have to run, it didn't see the file, therefore did not add the new files to the dependencies. So I should at least touch test integration simplification. Now it's forced to recompile. It will notice that it did not. Interesting. A touch wasn't enough. Wait. Oh, there it is. Combine source. That's weird, because I did not touch this file before. Oh, but I did remove a file that no longer existed, I suppose. Let's just do that. Force it to see this file and recompile it. There we go. I can remove that. Aha. Our new... Oh. Oh. Ooh, that's always fun. Not implemented yet. That's because we have something that uses a part of the language for which we don't have support in some of the phases yet. Clearly, this is the validation part. Wait, we have stuff that's not done as part of the validation? That's surprising. And also, why are we... Oh, yes, of course, the simplification happens after the analysis. Interesting. So what are we missing? What's the part? Probably the for loop or the range expression, I suppose. This is likely to be the case. If I look at validation expression, line 258, validate range expression is unimplemented. Yeah, everything linked to arrays and dynamic sized stuff is just not implemented. Okay. So I suppose that for now, our combined test, if I want it to pass, which I do, cannot have a for loop. Which is annoying, but not the end of the world. Okay. Let's try that. Ooh. Error roll not found X. Interesting. I should also really start doing some rendering of errors because this is unreadable. Okay, line 8 column 14, X not found. Oh yeah, here I'm doing a return X, but X is introduced here, so this needs to be 5, let's say. Ah, no, I need that to be, yeah, A. There we go. There we go. Now this passes. And we have a much better test suite than we used to have. And indeed, now a 4 expression is not tested. We don't test L values expression and constant expressions, I suppose. I guess I could try that. Because if I have a constant x, which is an int, which is a character, well, not x, I'm going to have some shadowing warnings. New line, character equals \n. This should not need to be simplified. Well, actually, I want... But constant unfolding is not the same thing as simplification. And this is the simplification test. I think it's fine to just keep it the same, okay? And I need to test L value expression. So I'll need some kind of struct. And in one of those branches, maybe here, I'll do a let y equal a foo of z equals 5 or something. And then I'll do y dot z equals a 8 times 1 times a, let's say. Return y dot z. This should not be simplified. Oh, actually, I could try. What kind of simplification? A 0 plus a. There we go. To check that it's also done in struct expressions. And here at the end, I should therefore have just that being a, and this is a again. Okay, let's just try that. Aha. Error passing on the line. So passing error on line 18. Is that this one? It's not. Isn't that the correct syntax? Or is it this? Yes, it's that. It's been so long since I've dealt with struct syntax. Okay. So that's a type error. Is not? Oh. Oh, the simplification did not apply to the struct expression. The simplification did not apply to the struct expression. I kind of want to change this test, actually. To do the diff. Yeah, I'm doing a diff on the show. Perhaps I want to do a diff on the pretty print instead. Yeah, okay, so I probably want to do a preprint expression. But preprint text and HTML are the name expression text, I suppose. This is gonna be preprint expression text. And that's just pretty expression or pretty typed expression. No, it's pretty expression. There we go. And that's a typed expression as an argument. Okay. And now here, I am gonna run, I'm gonna import the export pretty printing. Yep, that was exactly what it was. Perfect. And here, this is not going to be on show. This is going to be on pretty print expression text. Which means now the diff in the broken test should be the actual difference in expression rather than the AST version of it. So now y dot z equal a, but I got y dot z equals 1 times a. So it means somewhere this simplification is not applied properly, and that would be so that's in a let statement. We simplify, A typed expression, there we go. Yep, I don't handle the case of struct expressions in there. So let's fix that. Let's open the validated AST on the side so that we know what we're dealing with. This is representation AST validated. Let's look at a struct expression again. There we go. And the struct expression, given some struct info and yeah, a bunch of these are actually... Wait, I am using rewrite. I am using rewrite. Isn't rewrite the thing from plated? Yes, it is. Does that mean that my instance of plated for expressions is wrong? Because yeah, I shouldn't have to do this manually. Because it should be handled by the plated there. Huh. No, I do have fields here. So when I'm looking for typed expressions, I should be going through. Wrong one. Oh, it's in this one. So a struct expression does contain a non-empty, so I should be applying the function f to the typed expression here. That's what this definition of plated is telling me. I am handling struct expressions. Hmm. So that's a weird bug. Interesting, interesting. Just to check, I am doing a 0 plus a, and 0 plus something should be replaced by that. And that is applied on a typed expression using rewrite. And rewrite does go through. So on a let, I simplify the let value, and on an expression, it's a rewrite. Huh. That's fascinating. So why is it not applied there? Because that's not a constant expression. That's not an L value expression. That's a regular expression. I believe plated is fine. My instance looks fine. Can I try something else? Let's see. If I have a function bar that takes a foo as an argument and does absolutely nothing with it, what happens if I first do a bar of this value? But let's say a 1 times a here so I can differentiate between the two errors. I am expecting this to be simplified to bar with just a. And I need this function here also in scope that will not be simplified. Okay. Let's run that test. I wonder what the bug is here. Okay, so I do get the 1 times a again, so it really seems to be a problem with struct expressions specifically. Okay. Okay. So this test is useless, I can remove it. Oh, I think I know. I think I am looking at the wrong thing. It's not the struct, it's the assignment. I am looking at the wrong place. It's not the 0 plus a, it's the 1 times a. It is in the assignment that something is wrong. I am looking in the wrong place. That might explain. Okay. So, if I look at an expression statement, we do simplify it. It's just an expression, okay. Ah, but is it the plated that's wrong? Because this is an assignment expression that has a right-hand side that's an expression. That's what it is. My plated instance is wrong because I forgot about assignment. I also forgot about cast and range, it seems. Okay, so I forgot about a bunch of things. Oh no, wait, cast is here. Why are those not sorted in the same order as those? That's confusing. Let's fix that. Ooh, this is gonna be unreadable if I do that. So local variable expression is not needed. So we have index expression first. Function name expression doesn't need to. Function call expression does, and therefore it's there. Variable, array, struct, field access. Int negation, boolean negation, that's correct. Addition, subtraction, multiplication, there we go. Division, modulo, exponentiation, equality, difference, greater, lesser, greater or equal, lesser or equal, Boolean and Boolean or. So where's the cast? I saw the cast. Yes. Boolean negation expression here. Cast, you move all the way down there to be consistent with the ordering here. Range expression, I suppose it makes sense because range expressions are not expressions. So for plated, it doesn't make sense. Except no, because range expressions contain typed expressions. So no, it must be handled. So range expression needs to be handled as well. This is gonna be a I'm just gonna make a second function here for this, just because I'm gonna need to. So is that gonna be some kind of f map of visit range? I don't need f, it's already there. So RE, there we go, and I need a visit range. So it's a traverse. Visit range, and visit range is gonna be a case of there we go, except this is an exclusive here. Except this is just F, I think. Not traverse. There we go. Okay, so now we handle the range expressions that we didn't. And now we need all of those assignment stuff that we are not handling. To the point that maybe I actually want to remove this and guarantee that we handle every single case manually, rather than having a catch-all that gives us a false sentiment of like, we're safe. All of those are gonna be the same thing. Oops. And that is this. Okay. So now the ones I'm missing, I am missing the literal ones, which come after field access expression in the order. And nothing happens there, they're just the same. So it's just pure of that, nothing has changed. And those two here are also missing. Okay. And if I've missed any of them, I'll see that very quickly. It's fine. Okay. So now, oh, not here. Here. Traverse visit range. What's wrong with that? Oh, yes. Actually, it is indeed a traverse because those are things that are typed. So this is a traverse. And wait, no. What am I saying? What am I saying? No, 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 no. This thing applies on typed expressions. This is plated on typed expressions. So F should be applied on typed expressions. So what is the error? Let me read that again. Hmm. Let me think about this for a second. Oh, no, it's not typed. I already have removed that. So this is directly the range expression. Therefore, this is just the visit range here, which means I could rewrite this as there we go, and that removes the need for a local helper. Okay. Let's see if this works. Nope. Ah, that's just because lens also has a dot 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 operator, which is not the same as the one I am defining, so I just need to hide the one from lens. Let's see. That's not the way to hide an operator. I need to wrap that in parentheses within the parentheses. There we go. I saw the formatting kicked in, so that now I know the format is correct. Wait, what? Wait. Was I right about the traverse? I was right about the traverse. It's a typed thing there. So maybe I want to keep the visit range. Because I need to traverse the typed thing. Ah, but the problem is... Yeah, I think the easiest way is not to do a traverse like this, is to decompose this here. This is a typed. What is typed again? It has a concrete type and the value, okay? And I suppose this is a typed T of visit range RE, and this hasn't changed. Okay. Which feels like a traverse of some kind. Oh, it's probably a traverse of a compose or something like this. I think it's fine to keep it explicit like this, but I think it's basically, I could do it with traverse of a compose. Oops, not here, because I want to keep building with coverage. Okay. This, oh, that's what I'm doing wrong. That's what I'm doing wrong. There we go. This is a range expression. There we go. Yeah, I feel like there's a way to express this with traverse of some kind through typed. Is it just that? I feel like that's the case. Which means I can go back to just this here. Oh, except RE is now... okay. Control lens. So range exp. That's good. It's a good kind of error. Okay, and function name expression is missing, and it's one below index expression. There we go, and that's just name and function type info. And that's just pure of a function name expression with those two arguments. There we go. Hopefully now. Okay, that seems to compile. That's good. Now let's see if the test we wrote actually works now that we fixed the plated instance of our expression. God, compiling the parser is still a nightmare. But yeah, the upside of writing tests, we found some bugs. We found some rules we hadn't written. We found a bug in the plated instance of typed expressions. The test harness is already paying dividends. Now we just wait, as usual. That's the problem touching the AST. A lot of the code base depends on that. There we go. Did the test pass this time? It passed. Great. So let's check just it's there. Combine is here. let's now have a look at, did we cover more things now? We should have covered, do we cover the L value expression? We should be covering the L value expression. We should be covering the const expression. And the for statement should be the only thing we don't cover. Oh, interesting. So we did not run simplifiable on the L value expression and the const expression. Is it because for the const, that makes sense because we only run simplify on the functions and not on the constants. So this instance is not used. L value expressions, however, we should have. No, we don't, because we are using rewrite, which is the plated part. And there are no expressions in an L value expression, right? Yeah, there isn't. So in this case, it just means that in the simplification phase, we should be able to remove those two instances and the code should still work the same. And we probably want to add some dedicated tests. Okay, there we go. So it still works the same. The instances are no longer there. For is the only thing that's not tested because we don't handle ranges and for loops in the validation phase yet. Now I think I want to add a dedicated test for assignment, given that we had a bug there. So let's do that quickly. Let's add an assignment source, which is going to have just a function foo. That takes nothing, returns nothing, that's fine. Declares x an int, which is equal to 0. And let's then have a look. What operators do we have? All of those were missing. Assignment, addition, subtraction, multiplication, division, modulo, exponentiation. Okay. So let's try that. Just gonna copy that as a comment just to have it as a reference. So we want to try x equals, let's say, I'm gonna need something that uses, I have already x, it's fine. X times 1, then x equals x, well, then plus equal x minus 0, x minus equal 0 plus x, x multiplied equal of 1 time x, trying a bunch of different ones, x modulo equal x divided by 1, and x exponentiated by, and this one, no, we still need to check it, it's going through, so we still need to do something, but I can reuse one of them already, it's fine. Let's just say x plus 0, there we go. So that's our test. And the simplified version of this should be x equal x plus equal x. It should all just be x everywhere, unless we've messed up. Okay, I will probably need to just make a trivial change to this thing here. Oh, actually, let me check something. I have this test locate here, which is a bit of template Haskell nonsense that allows me to list files in a directory at compile time. And I have this add dependent file, which is part of template Haskell. Can I do that on the folder so that it auto detects changes to the folder as a whole, basically? So language th syntax, there we go. Add dependent file. There you are, but that's not the version I'm looking for. There we go. Expect an absolute path. That file path, not a folder. Okay. Let's see. It's not documented here. But let's have a quick look if template Haskell add dependent file folder. Let's see if this answers my question. That's not the question I have. Okay. I guess there's one way to test this, which is to test that. And this would be, given a directory there, what happens if I add dependent file, the directory instead of the file, well, on top of the file. Will this break? Will this complain? What's going to happen there? Inappropriate type is a directory. Okay, so that doesn't work. That's a shame. So that means I have to make, when I add a test, I have to guarantee that this thing is recompiled just so that, that's annoying. Oh well. Okay, the assignment test is passing now. That's good. Okay, so this assignment test that we wrote just worked. That's neat. Okay. Just to make sure, let's introduce a bug. And indeed, we are expecting perfect. So it confirms that this is being run properly. Okay, so now we should be back to having pretty decent coverage now on the tests that we've been adding this evening. Okay, so if I look at this now, I also want to have a quick look at test. Yeah, I have integration. Yeah, parsing. Okay, I wanted to stop here, but I'm going to have a quick look at, since basically I wanted to add tests for each of the phases. That's a big thing. And then start adding end-to-end tests that compile actual files. We'll do that next time. But let me have a quick look at parsing. Let's see how bad our coverage is. Or how good. Maybe it's very good. We'll see. If I look at parsing, it's not that great. Let's see. We never run the lex function. We never run the parse expression function. Okay, so we only test parse module. That would probably be worth adding, but it's not the end of the world. Oh, interesting. Alex tab size is never. Well, that's generated Alex. Yeah, that's generated Alex code. That's unreadable. That makes sense. We don't have a single predicate on rule, so I think it makes sense for this to never be read. We don't have user data. That makes sense for this to never be read. Yeah, the Lexer is going to be very error not happening. That's always good. Oh, aha. This is interesting. In our passing test, we never test the range operators. We never test greater or equal, assign division, make a comment. Oh, that's fun. So that should be fairly easy to fix. We could try that quickly, and then I'll stop for the evening. If I look at the parsing, I have this basic, has a bunch of things. I suppose we do cover some of the stuff in other. Wait. Division assignment expression. Didn't we just do... We didn't do the division. We didn't do division. So I should divide this. Let's look at our simplification phase to see anything else that I should have thought of adding. Ah, yeah, exponentiation by 1. There we go. I can do that. And in the simplified version, we need to add the division. There we go. Now, if we go back to basic, we're missing division that's done. We're missing comments. So we should also add a comment here. And a comment there. What's the syntax I've used? Probably this one. And in theory, if I look at basic.golden, I could not put them, the comments should be removed, so it's fine to not add them here. But I probably want to add some kind of this if x42 could be an OX42 here, which will be replaced by its decimal value here. Which is 66. Okay. Let's try that. Okay, one test failed. Uh-huh. What is different? Oh, yes. I suppose those comments added an empty line. Wait, no. Ah, weird. No, it should make no difference. I should be able to keep those lines. So let's rerun with this. And I want to rerun with SP basic. Isn't that what it said? No, I'm an idiot. What? But I am giving it the double dash that signals that those options should be. Oh, unless stack test actually requires a different syntax. Let's have a look. Is it a test option, something like this? It'll take me more time to figure that out than just rerunning the tests, so let's just rerun the test. Let's copy this. And let's put it in a file. And let's do a diff of the basic golden files. It is the same. So it's telling me that the files differ, and the output it's giving me is the same. What in the hell? Is it some spaces that remain that shouldn't be there? That would show as a difference, right? If I try to replace here like this, and let's remove. There's also an option which is trivial, which is I could. Yeah, it's telling me 66, so I was right to fix it. There's something I could do. I could also just remove that file and let the test recreate it, and then do a diff again and see what's different now. Oh, that's a bug. Ooh, that's a nice one. Because now it's printing 0x66? No, that makes no sense. Wait, what? Oh, I'm the one who wrote the 0x66. I'm wrong, right? No. No, I'm the one who wrote it and I was wrong. It should be indeed 66. I wrote this wrong because the basic version is OX42, which is, yes, okay, so I wrote it wrong and I was too tired to figure out the difference. If I was too tired to figure out the difference, it means I should probably stop here. Because now this is correct. Okay. Now if I look at this, we are passing all of those things. There are still some states in the Alex state machine that we are not encountering. I don't know what those are. That's Alex action 63, make identifier, huh. But that's in 48. What is 48? Oh, it's a bunch of cases where we want to make an identifier, but we don't. We never encounter the state where we need to make an identifier. Is that because... Yeah, this is unreadable. Alex generated code is just absolutely unreadable. Yeah, no, I'm not gonna worry too much about this. At least we've checked that all of those actions have been seen at least once, which is good. We still don't test anything here. This is... Oh, interesting. Don't they test applicative or monad error? Oh, I think monad error diagnostic is incorrect. We don't do that anymore at all. Applicative should be there. It's weird it's not used, but that's fine. Parser state... That's because... No, that's weird. Oh, no, that's because we don't pass any Unicode. We should be passing... Oh, we don't pass Unicode. We don't have variable names that require Unicode at all in our tests. That's why this never happens. Alex error is never encountered because we don't have negative tests. We don't have tests that something doesn't pass. That's expected to never... Yeah, that makes sense. Alex error, that makes sense. We don't do a lot of handling string literals because we don't support really strings yet. And we don't have any happy error, which is fine. We'll need some pass error and lex error tests at some point, but we're not there yet. Okay, so I guess one thing we could do is, at the very least, test the bytes logic. We already have test of the encoding, but we can make that a bit better by having a passing of a variable that's not something that fits in one byte. If I look at my unit tests and my encoding, I can just copy this kanji, I suppose. And that's the name of my variable here. Except I am on the wrong file. So now this should be fine. I can remove this file. I can rerun the test. It's getting late. I should stop for the evening. Ooh. What has changed? This error is unreadable, so let's do the thing I've done before, where I move it to a different file, I rerun the thing, generate a new golden file, and then do a diff of them. God, that's the only thing. Okay. That's silly. I should probably just change my pretty printer then. Because every time I edit this file in Emacs, I'm going to introduce a new line, and every time I'm going to have the same issue. So can I change instead pretty print text to put a new line at the end, basically? So that would be going back to pretty printing, and that's the past version, I suppose. AST past. Okay, so set by new lines, is that a function that's coming from... No, it's coming from probably the pretty printer render text. There we go. Step by... No, okay. Do I have anything... Oh, I have some common here. There we go. Okay. So I probably want... So this is simply sep by new lines, and then hardline, which means here in my thing here, a module is a sep and by new lines. And same goes for the AST validated. Where is the module? Where do I have sep by new lines anywhere? Okay, in symbol cache, where do I use pretty symbol cache? Here, pretty interface. Okay. Oh, so here this is just... I could replace this, but it's fine. I'm just gonna put a hardline at the end. Okay. So now if I do this, I'm gonna have a bunch of files that are gonna be wrong. At least the golden one. Unless I've already touched it, and therefore it's gonna be already fixed. Let's see, is anything broken? Yep. The basic one is broken. And now if I go back to the basic golden file and I save it and it adds a new line, now it passes. Okay. So if I go back to what I was looking here, at least now bytes should be... Oh, no, it's still not covered. Very interesting. Parser bytes should have been called. Oh, but we use a lens. we use the lens, so we never use those values. That's why. Because here we do use sparse allocation. We use all of them, but we never use the actual field. We only ever use the lens, which is not counted. That makes sense. Okay. That's fine. And the last thing we wanted to do, if I go back to parsing, wrong one. I want to remove this monad error here. We never use that. It doesn't hurt to have it, I suppose. Wait, we never use it? But we need it because it's the throw error. No, okay, it's fine. It should say. Okay. And last, if we look at the happy thing, we never see happy state 45. Yeah, there's a few happy states we don't see, but I don't want to debug the grammar to figure out what exactly we don't. Probably, yeah, range expressions in all likelihood. But I don't want to debug this because it's a nightmare. This is already good enough for what we have now. So let's do this. So what did we change in minimization actually? We only added more coverage for things we had missed. And none of the things we touched are about... Yeah, okay, so we can commit this on its own. Next, what did we do? This file can go away. So we've removed those simplification things. We've added a bunch of new ones. Did we touch the valid simplification phase at all in the test? We did. What did we change? Oh, yeah, but that can be a separate phase, a separate commit. Okay. So this is there we go. Now we want to add this on its own and not this one. There we go. Which we can then include into this commit, this test. This is just, we are now importing the pretty printing and we are using that. Okay. Next, let's do I can't do that without touching. Okay, so let's do that quickly. I should run Weeder at some point as well. But there's so much code that's not used yet that it's not very useful just yet. Wait, why is this modified but the golden file is not? What the fuck? Oh, did they make a mistake there? I think I did. I think I did a thing that's wrong. Yeah, I have a git ignore here that removes the golden files. The reason I did this is I wanted to test to always run... No, I don't know why I did that. That's completely wrong. That's completely wrong. The whole point of a golden test is that we are comparing against a known value. If I regenerate them every time, the test is useless. So that was completely wrong. Okay, well that's fixed. Yeah, it's not the best comment, but it's fine. Okay, so that's the work for this evening. I'm gonna check quickly for once that it actually passes on GitHub. So now that should be fine. Am I not logged in? I am logged in. Ah, the badge Twitch live works. That's neat. Okay. Oh, I haven't run hlint manually in a while. What do you have to offer? A few things. Interesting. Let's have a look at those and see if they are interesting. I guess none of them are errors, since the checklist here has passed. What are you saying? 39. Yes, I suppose I don't need to do this. I could do a traverse and just give it a dot here and make it point free, but I am fine without making it point free. Likewise here, I am fine with the naming the thing explicitly, not making it point free. You're right about this one though. I have a function here that's just that. It could be a new type. So let's do that. Yes, I suppose that's unless. I don't mind that. Of course, the dollar could be removed, but this will be at some point something else. In fact, I can immediately do a do block here instead. Yeah, that's correct. I disagree with you here, I think. Use drop while. Ooh. Because here I do a break on equal base name and I take the second part. That's the same thing as doing a drop while. Okay. Thank you, GHCI. GHCI. Um, HLint? Why am I? Yes, HLint. Why am I? I'm retired. I should stop. Wait. I break on equal base name. Let me just check that HLint is correct here. Data list. I do a break. Apply. Do not satisfy. Okay. So I will return. I will break on the first element that matched this. So I should drop while not. Yeah. Okay. I think that's correct. New type instead of data in resolution monad. What? Resolve. Oh, this thing, yeah, I suppose. Redundant, yeah. I like it, it's more readable. Redundant bracket. Yes, I suppose. Yeah, that's not wrong. Let's do that. Fuse traverse map. That seems like a good idea. But wouldn't list fusion do that for me anyway? That I suppose it's not a bad idea. So I can do that and that. Wait. Yeah, okay, so it needs to be that. Wait, that makes no sense. There we go. Zip with m. Yeah, I'm doing a void of a zip with. That's indeed a zip with m underscore. Actually, this is correct there again. Avoid restricted function. Error. Yes. Okay. Where's that template? Oh, that means I have an error and not a report like in internal compiler error. That's a good. That's an actual real problem. There's so many of them. Okay, I'm almost done. So this means template here needs to import internal diagnosis. I need the internal compiler error, and this use of error should be a report ice, and that's in read template. The error is unknown character, and there's no additional thing. Okay. Use new type instead of data. Okay. Have a few of those where the thing is down to only one field and therefore it could just be a new type. I don't use this one. I disagree. And that's it. Okay, perfect. Let's check. Oops, I am on the wrong. I'm just gonna do it here. Because I don't want to recompile everything with the new flag change if I were to just do a stack test or something. So let's make sure that those last minute changes actually work. The thing is, I'm surprised. Why didn't the CI caught any of this? Because it passes, it builds and everything, that's fine. But check lint should have okay, warning 12 suggests 19. I should change it so that the warnings are errors in CI, I think. Okay, so the tests still all pass, perfect. And let's also check that the build, the stack action did in fact also run the test. It did not. It did not. Okay, so we really need to fix a few things in our CI. So first, let's add this, which is a bunch of very simple suggestions from HLint, including a very big one here where we had a raw error instead of a proper internal compiler error. I don't have... And now let's have a quick look at our GitHub Action workflow. So first thing is, why is the highlighting wrong? Well, test true, first of all. And I guess this is HLint run. Let's see if this has an option to run in a way that reports the warnings as, there we go, fail on. Default never? Huh. That's, yep. That makes sense. So the hints would be displayed as annotations in the pull requests, but at the moment I'm just pushing to dev directly. So we should probably, yeah, I think I want to make it fail on. Let me check quickly. If I run it now on lib, do I have any? I do have warnings. Okay. And I disagree with them. Yeah, I disagree with them. So maybe I should not make it. I should make it fail on air, I think. Especially since I have a custom. Like that, I think those should be an errors. Should be errors. Let's try actually. What happens if I go back to here and I add a undefined here? Is that labeled as an error, as a warning, or a suggestion? It's a warning. Okay. So I want to make that an error and make this fail on error. So I need fail on error in the configuration of the GitHub action. There we go. And now I need to figure out when I create a custom when I create an additional hint. How do I make this an error? Let's see if it's documented anywhere. Maybe I cannot. Hmm. Well, that's not documented, so I don't think I'm gonna spend more time on this. That's fine. Or could I? Could I make it so that error error what happens if I do that? Does that work? Does this make it actual errors now? Nope. Doesn't work. Or is it because I need to do name? Probably that. Well, except I removed it, so let's go back to here and put an undefined here again and check that. Oops, sorry for the noise. Now this should be an actual HLint error if everything works the way I expect. Why did it not? Did I not save properly? No, undefined is used. Oh, I'm an idiot. That's the name of the function because that's the special case here. So I can't use a string here. So this needs to be this way, which means if this syntax works, it has to be defined this way. I'm not sure it works. Aha! But it is still a warning. That did not manage to make it an error. Okay, so this did nothing. Okay, well, too bad. But we still fail an error, which is better than nothing, and run the tests. Um, and now this should be the last thing I do this evening because I wanted to stop before midnight, and it's half past midnight. I've been at it for 4.5 hours. This was productive, but it is late. I should stop here. So let's just quickly check that now the last action passes. And let's check that now there's way fewer of those. There's a few. Oh, there's more here. Oh, because it checks some of the other modules, of course. Yes. It checked the tests. It checked a few things. That makes sense. Okay. But no error, so that's fine. Formatting passed. And now build. This time we should be running the test. I suppose I had set tests to no because at first they were not compiling. Okay, now it seems to all have passed. Perfect, and now we are back to having dev building, the dev branch passing. There we go. Okay, so that was fairly productive. The big thing is we've fixed and added some integration tests for some of the big phases that we have in the, well, for some of the small phases we have in the code. Next time, I think we start working on end-to-end tests where we actually run the compiler, generate images, like test that all of this works, including starting to test of like, oh, this should not compile, for instance, and have some golden tests probably for some images at the very least. That could be good to just run through the entire pipeline with the. Actually, I probably want to not check the images, but I probably want to find a way to invoke npet, the interpreter, on the generated images and test their behavior. That way, if we change the implementation, if we change some optimizations, we should still check with our end-to-end test that the behavior is the same. So I think we're gonna do that next time. More end-to-end tests, and probably start working on rendering errors in a way that's better so that we have better error messages, so that we can then also test, add integration tests for the validation phase, which is the biggest phase of the entire project and for which we have 0 test. So, yeah, that's about it for this evening, I think. We're still in the middle of adding tests. Again, if you've joined late, the reason why I'm adding so many tests is we're at the point where parts of the, like, we are able to run the compiler, but so many features are missing. We're gonna have to rewrite some parts of the compiler to be able to support missing features. And I want to have as robust as possible a test suite before I go and make deep changes to some of the code that exists. So that's why for the foreseeable future, we're writing tests, because none of the code of this project happens off stream. For now, I'm going to stop here because it's late. So thank you everyone for tuning in, and I'll see you all next week.